Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode BiWeekly Contest 79. The problem name is Maximum Total Importance of Roads. It's a medium level problem. I would say it's a relatively easier problem as compared to the other problems that we received uh, in other contests. So the problem says that we are given an integer n denoting the number of cities in a country, and the cities are numbered from 0 to n minus 1, and we are also given a 2D integer array roads where roads of I equals to ai comma bi, which denotes that there exists a bidirectional road connecting cities ai and bi. So yeah, a typical graph representation till now. Now what we need to do is that we need to assign each city with an integer value 1 to n, where each value can only be used once. Now, the importance of a road is then defined as the sum of the values of the two cities it connects. So that means you have n nodes, and you have some roads connecting these cities, and we need to assign each city a value ranging from 1 to n. You can use a value only once, and such that the maximum total importance of all the roads is the maximum possible value, and the importance of a particular road is the sum of values connecting two cities. Now if we look into the example, so we can see here, or let's come to the diagram. Probably I'll explain you with the help of a diagram. So if I come here, remove the pen. So suppose that we have a graph, something like this. This is connected to this is connected to this, and we have this, something like, and suppose this, so, and this. Okay, so we have a graph. Suppose we number the nodes from 1, 2, 3, 4, 5. So these are the 5 cities where we have, and we have some roads. These edges represents the roads. Now we have 5 nodes, so we have 5 values. Actually, the nodes are numbered from 0 to, let me add one extra thing. So it's 0. Now we have 6 nodes. So because for n nodes, the cities are numbered from 0 to n minus 1. So that is why. So suppose n equals to 6. That means we have 6 cities. So these are the cities, and we have some edges. Now we have uh, 1 to n numbers as well. 1 to n. Now out. So we need to assign one number to each city such that the total maximum importance is maximized, and the importance of a particular edge is denoted by the sum of value that we assign to this node and this node. So for this road, the importance will be sum of the two roads connecting this or the road connecting two cities. So yeah, that's the problem. Now if we look closely into this particular diagram, so how will the sum be maximized? So for this particular node 2, if we look at this node 2, suppose we assign value x here, right? Suppose we assign value x here. So that means what will be the sum? The total importance will be sum of this edge, this edge, this. That means all the edges. Now if we calculate the sum, so for this edge, if we look into this edge, so what will be importance of this one? Suppose this is y. Suppose this is y. So it is y plus x. For this it will be y plus x. For this, suppose this is z. So it becomes x plus z. Suppose this is w. So this becomes x plus w, right? So for each edge, we can see what is the value. Now if you see here, so for these 3 edges, x is being included 3 times because this contributes to the sum of 3 edges, right? So that means if we assign maximum value to this, if we assign a big value, or not the maximum right now, suppose we assign a big value to this, our sum will be maximized because this is contributing 3 times to our final answer. However, if we consider another node, suppose we consider the 0th node, and suppose we assign a big value to this, suppose or let's suppose we assign it a value a. Now what will happen, the importance of this edge will be, suppose this is b, so it will be a plus b. Now if we assign a big value a, that means if a is a value having higher magnitude, then we see that this will be contributing only one time in the total sum, right? This will be contributing only one, because it will be contributing only in this edge, right? Because it is this node is not connected to any other edge. So that means the nodes which have maximum edges going out of it, we need to assign maximum values to those, so that more number of times a greater value contributes to our answer, right? So in this case, we can see if we assign the maximum value to this node, because this has three edges, 1, 2 and 3. And there is another case, one two sorry one more thing is there. Here is a cycle. We can see that this node has four edges, one, no, just three, 1, 2 and 3. So we can see these two nodes have three edges here. So we can assign either maximum value to this one or maximum value to this one. It won't matter to which node you assign the maximum value, because here also if you assign 100 or here you assign 100, the final answer will have 3 into 100, because whether you assign 100 to this, it will come three times, or you assign 100 to this, it will come three times. So another possibility is that you assign 100 to this one and 99 to this one. I'm just taking an example because 99 will be the second largest value. So we see that now it will be 3 into 99. So the final answer is going to be same. All you need to do is that you need to sort the edges, sort the edges having sort the nodes having maximum edges, and assign a value based on that. So yeah, now let's look into the implementation. This was the main crux of the problem. The implementation is pretty simple, I would say. If you want to look into an example, we can look into this, that okay, this is a graph that we are given in example number 1, and we can see here that here we have 2. The node number 2 has maximum number of edges, 1, 2, 3 and 4. So we have assigned maximum value to this one. Now when we come to node number 1, it has 1, 2, 3 edges. We have assigned it to, so we say we have assigned 4 here. Similarly, node number 3 has 3, and node number 0 has 2 because it has 2 edges, and the least number of edges is present at 4. So we assign the least value, possible value, to 4. And then all we need to do, if we sum all this, we get the final answer. Now summing is a technique that obviously you can calculate the weight of each edge and then sum it, but that is not the optimal way. We know that for each edge what will be the contribution. So here if we come, we initialize a variable answer, and we count the frequency. We count the frequency of edges for each node, right? So for each edge, we count that each how many edges are connected to a particular node. So this array will have the frequency. Now we sort it, because irrespective of which value has what, we just need to assign the maximum value to the node having maximum number of edges. So the only the number of edges is relevant here for us. So now answer equals to answer plus edge count of I. Now edge count of I is the maximum number of edges a node has. So that multiplied by I plus 1, because we have values from I to n. So that means value n will be assigned to the maximum edge count. Similarly, the value n minus 1 will be assigned to the second maximum edge count, and so on. And finally, we have our answer. The one point to note here is that we need to typecast this value, because again the answer can have the return type is long, and it can overflow for larger value of n. And like suppose one of the nodes has 10 raised to the power 4 edges and something like that. So again, but the total answer can overflow. However, I can see that the total the range goes from 5 into 10 raised to the power 4. So even multiplying it will 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 go to the will go close to the maximum value. 10 raised to the power 4 into 10 raised to the power 4, that comes to 10 raised to the power 8, and 5 into 5, so it will be 2.5 into 10 raised to the power 9. So yeah, very close to the boundary value, I would say, but the total sum can obviously overflow, so we need a long variable here. And finally we return the answer. The time complexity again will be big O of n, because we just traversed it a couple of times, and the space time complexity will be space complexity will be the number of the number of nodes that we have. So yeah, I would say a tricky question, but relatively easy from what you get in other contest. The third question in other contest. So yeah, hope you learned something new from this video, and do if you like this video, then do give it a thumbs up, and take care. See you in the next video. Thank you. Bye bye.